In this video, I'm going to look at the part 2s, otherwise known in this world as the FRQs, free response questions. There are 4 of them, and each of them has a bunch of little parts to them. And 2 of them, you are permitted to use a calculator, and 2 of them, you're not permitted to use a calculator. So I think these first 2, you can use a calculator. Let's take a look. The domain of f consists of the 5 real numbers 1, 2, 3, 4, and 5. And then there's a second function, g of x equals 2 ln x. So this first function, you could say like f of 2 equals 3 and f of 3 equals 5, but you can't say like f of 2.5 because it's only defined for these 5 values. Okay, let's look at the questions. A1, the function h is defined by, I like it this way, g of f of x. So that is, they want to know what's h of 4. H of 4 is g of f of 4. But f of 4, according to this chart, is 3. And g of 3, when you plug 3 into this equation, is 2 ln 3. And then they want a decimal approximation. So that's where you pop up your calculator and type 2 ln 3, and we get 2.1972. I'm not sure. It says in the instructions that I don't have handy how much approximation you need, but that's 4 decimal places. And that's A1. A2, when is f of x equal to 3? Well, for this one, we can see on this chart that f of 2 equals 3, but f of 4 also equals 3. So for 2, so this was 1, okay. For 2, there's 2 numbers, 2 and 4. I'll put them in a little set. Okay, now for B. Find all values of x for which g of x. So notice how the first one asked for f of x equals 3. There were 2 answers. G of x equals 3. We say 3 is equal to 2 ln x. I would divide both sides by 2 first. Now, ln x basically, so in general, you can take any log equation, just go on the side, log base b of a equals c, and rewrite it as b to the c equals a. Those are like equivalent to each other. That's what the log means. Ln is a fancy way of saying log base e. So this is equivalent to e to the 3/2 equals x. Those are, you can always take an ln equation and basically write this as e to the whatever is after the equal sign. Ln x is a fancy way of saying of log base e of x equals 3/2, and log is a fancy way of saying if log base e of x equals 3/2, that's asking what power do I need to raise e to get x, and it's 3/2, so x is equal to e to the 3/2. And on the calculator, if you push second ln, if you're using a TI calculator, it does e to a power, and we end up with about 4.4817. So that's B1. These are all worth like 1 point each or something, all these parts. 2, end behavior. So G, if you were to graph it on the graphing calculator, it would look something like that. So the end behavior, as x gets really big, as x goes to infinity, the bigger x gets, the bigger the y value gets. So we say g of x is equal to infinity. Now, on the other side, they're probably not going to want the end behavior because it kind of doesn't have end behavior. I mean, maybe this end? I don't know. Remember, you don't have to get 100 on this test, but you might want to describe what's going here. The way you describe that as the limit as x approaches 0 from the right-hand side of g of x equals negative infinity. I'm not even sure if they would want that necessarily, but it would be accurate. It would be true. They may not care about that. I'm not using an answer key. Sure, I should. Okay, so that's, I see, as x increases without bounds. So no, they only want to know this answer. Okay, and that takes care of B. Now for C, determine if f has an inverse function. So an inverse function is where, so we say like f of 3 equals 5. And if it's an inverse function, f inverse of 5 would give us 3. So it seems like you could just undo everything, but you notice what we look for in a question like this is, are there matching values in the f of x? And there are. So because of this, we'd have a problem, because if I say what's f inverse of 3, we don't know whether to say 2 or 4. And because of that, the answer to this is no. I would just say, because f of 2 is equal to f of 4. That's what I would say. That is the reason why. If you have two function values that are the same, it can't have an inverse, because you wouldn't be able to invert it at that value. They both equal 3. Okay, number 2, still in the calculator section. An ecologist began studying a certain type of species. So the species grows, usually that's exponential. In 2015, so this is years since 2013. So in 2015, which they're calling t equals 2, there were 59 plants. So that's like a dot there. And then in 2021, which is year 8, there were 118 plants. Notice how that's actually double. They don't make it that clear, but it did double. So in 6 years, it doubles. So it doubles in 6 years. It's going to double again in another 6 years. Maybe I should bring this down. Oh, maybe I can move the whole thing. Yes. So it doubles from here to here, and then it's going to double again to 236 after 6 more years. So we get that exponential shaped curve. Okay, what do they want to know? They want to find the equation of this. P of t equals a times b to the x power. Well, the way you do that, and for number 1, they sort of give you a hint on how to set it up, and 2 is actually to find the equation. What you do is you take the 2 points you know, which are 2, 59 and 8, 118, and you plug it into this equation. So it's 118 when x is 8, and it's 59 when x is 2. Those are the 2 equations that they wanted for part 1, and then they want you to actually calculate a and b. You do that by dividing, and when you divide, you get 2. The a's cancel out, you get b to the 6th power, so b is the 6th root of 2. Now, they really want you to be careful on your calculator. So I'm going to go 2 to the 1/6 power. 2 to the 1/6 power. And I get b is approximately 1.1225. But I'm going to be extra careful because they want us to calculate out a. Now, according to this equation, a is 59 over b squared. So I'm going to leave the actual b value with all the decimals in the calculator, and then I'm going to do 59 divided by, I go second ants and then squared. This way my A value is as accurate as possible, whereas if I were to round my B value to 1.1225 and plug that in for here, maybe it's not as accurate. So that's A and B. And that's the answer to A there. Now let's look at B. Use the given data to find the average rate of change. Average rate of change is like slope, basically like the slope of that line. So the average rate of change is y2 minus y1 over x2 minus x1, which is 59 over, 8 minus 2, 59 over 6. 59 over 6 is 9.83, like that. That's the average rate of change. Now they ask a really weird question. They want to know what's going to happen at 10. Now, 10 is up here somewhere. But they're asking what would happen if instead of finding this point, because maybe I don't want to plug 10 into that, that weird equation with the whatever we just got, y equals, I don't have that one handy anymore. But we had that equation, the a times b to the x. Maybe I don't want to plug 10 into that, because then I have to raise b to the 10th power and multiply it by a. So we could approximate it by continuing this line a little bit more, up to 10. So the way that would work is it would be higher than 118. So here's 118, but you would add 2 more units, but each unit it goes up by 9.83. So I would just multiply that last answer by 2 to go 2 further units, but add it to 118 because it started at a height of 118 at that end point, and I get 137.6. It's a weird question. Then they say the average rate of change in 1 can be used to estimate the number of plants so for 10, it's pretty close to the actual answer, but if you went further than 10, that line would get further away from that curve. So they say, will the estimates using the average rate of change be less or greater? The estimates will be less, though. Will the estimates found using the average rate of change be less than or greater than the number of plants predicted by the model? Well, it's going to be less. Not just they say for t is greater than 10, but I would say it's true for t is greater than 8. Anytime you pass 8, this line is below the curve, so it's going to be less. And then finally, they say, for which t value, t equals 6 or t equals 20, should the ecologists have more confidence in using the model P? I'm actually torn on this, because 6 is in between 2 and 8, so the model would be, pretty good estimate. Not the line thing, but the exponential equation model. On the other hand, 20 is a really convenient number, because remember, every 6 years it doubles, 2 to 8 it doubles, 8 to 14 it doubles, and 14 to 20 doubles also. So it would go from 236 all the way up to 500 to 472. So I've gone back and forth on this. You'd think I'm making a video. I should have the answer key handy. But I'm going to say t equals 20 because we know that it doubles every 6 years. But so I'm going to say that because we know the exact value. The other one's just a model. So 6 might get us a close answer, but 20 is going to get us an exact answer. But if they asked 6 versus 21, I would say 6 then, because those would both be approximations then. But the 20 was just a convenient thing that you'd have to notice that 2 to 8 was 6, and 8 to 14 was also 6. So 14 to 20 is 6. So that was kind of a weird question. I could make an argument for either of those. Okay, now for number 3, they want you to put away the calculator. And this looks almost like when I looked at this first, I thought it was like a gear, but it's not. It's just a picture of a clock and then a close-up of the clock. And what they tell us is that the hour hand, which starts pointing directly up, goes around this way, and the tip of the hour hand goes around in a circle. And when you graph the height above the ground of the tip of the hour hand, it starts off at a sort of a high point, and then it gets lower. As this goes around, it gets down to a slow point, and then it goes back up and continues doing that. And they want to know let's see what they want to know. They tell us that the distance from the center, from the ground to the center of the clock is 200. And they tell us the hour hand itself is only 10 centimeters long. So if I'm here, so when the clock is pointing straight up, it's 200 to the center and then 10 more, or 210. And that's why the high point of this curve is 210. And then when 6 hours later, it's at the low point, which is going to be at 190. Because 200 is the, this is 200, this is 10, so that's 210. But if you go down 10 from the 200, you get to 190. And 200 is right in the middle. So that's our picture. But what do they want to know? Right here. Here's they're giving us the graph for 2 full cycles. And they want to know the coordinates for the 5 points. Well, to me, F corresponds to this point. So that's 0, 210. And then 6 hours later, it's at 6, 190. And 6 hours later, it's at 12, 210. These other points happen at 3 o'clock, so 3, 200. See, if when it's pointing this way, it's the tip of the hour hand is the same height as the center. And also 9, 200. That's what I would say for A. Now for part B, they want the equation. So they want it as a sine. To me, it looks more like a cosine. So what I would do, I'm going to start from this point, and I'm going to actually keep going until I get to the middle again, which is 15. Because this looks more like a sine curve. Now, the way you get the equation of the sine curve, the midline is 200, so that's going to be the sort of the d value. And the amplitude is 10, because you go up 10 and down 10 from the middle. Now, this is a sine curve, but notice how it goes down before it goes up, so we put a negative before the 10. There's also a shift, because the starting point is not at 0, but it's at 3. So I put parentheses, x minus 3. But there's also a compression factor, because sine curves usually go as a period of 2 pi, but this has a period of 12. So the b value is 2 pi over the period, which is 2 pi over 12. You could write that, or you could reduce it. And that's the answer for the equation. That's a lot of work for B. And now they want the graph and the t. Oh, wow, where do they at? Look at all this stuff they're asking. When is it positive increasing, positive and decreasing? Wait. Refer to the graph of H. The t-coordinate of J is T1 and the t-coordinate of K. Oh, there's 2 different points here. Let's go back to the other page. It's talking about J and K. So let me erase a little of this because I can't see where the J and K are. Okay, so they're talking about this j and this k. What do they want to know? Oh, it's a multiple choice thing. Which is true? What's h? Oh, h is positive. Well, it's above the x-axis, so it's positive, and it is increasing. I think it's positive increasing. On the interval, which is true. Oh, but then they want to know, describe how the rate of change is changing. Okay, so rate of change changing has to do with something called concavity. Like, you could be increasing like this or like this. In this one, not only is the function increasing, the one on the left, but the slope is also increasing, whereas the thing on the right, the function's going up, but the slope is getting less. We call this concave up and concave down. It's kind of like part of a smile. That's when you have a smile, part of a smile, its rate of change is increasing. And when you have a frown, the rate of change is decreasing. And between J and K, it's part of a smile. So, and you can also see it's going kind of like that. The slope itself is increasing. And this was a question about concavity. This one is the rate of change. The rate of change is increasing. So not only is the function increasing, but the slope is also increasing. Okay, now the last question. The functions g and h are given. Okay, so they have these two functions, and they want g of x equals 3. So you say 3 equals log base 4 of 2x. You could rearrange this to 4 to the third equals 2x, or 64 equals 2x, or x equals 32, which is the answer for 1. H of x equals e to the 1/2. So you do a similar thing. You go e to the 1/2 equals, and that other equation is e to the 1/4 in the denominator and e to the x to the 5th. What I would do is cross multiply and get e to the 1/2 times e to the 1/4 equals e. Also, e to the x to the 5, you multiply the exponents together, so 5x. You combine these by adding the exponents. And now, because they both have e as the base, you can just say 3/4 equals 5x, divide both sides by 5, multiply by 1/5 is even easier. 3 over 20 equals x is the answer for 2. Now, for part B, let's see. Here we have new functions, a log and a trig. So they wanted to rearrange or rewrite this expression. So there are these 3 log rules, and they are that log base b of xy is the same thing as log bx plus log base b of y, and that log base b of x over y is log base b of x minus log base b of y, and that log base b of x to the a power is a times log base b of x. Those rules work in reverse also. Okay, I'll have to continue with this. Okay, so with these rules, we can combine these 3 things into one big log. Basically, what ends up happening is I could combine these first 2 using this rule. So it's going in this direction, though. I have log minus log, so it turns into log 10 of x plus 1. Oh, rats, sorry. We should definitely, if you ever see a coefficient in front of the logs, use this rule first, but in reverse, where the coefficient gets moved to become the power. So I'm just going to put this 5 up here first. Now I can combine using rule number 2. So it's x plus 1 over 2 minus x to the 5th. But I still have plus log base 10 of 3. Now I could use rule number 1 in reverse. Log plus log is log of a product. So it becomes log base 10 of x plus 1 times 3. I'm going to put the 3 in the numerator. And that's the answer. That's a lot of work for number 1. For B2, they want to rewrite this in terms of tan and sine. So for that, it's basically a trig identity. In other words, I take secant x minus cosine x. So there's various trig identities you have to know for this test, and one is that secant is 1 over cosine. Reciprocal identity. Secant's 1 over cosine, cosecant's 1 over sine, cotan is 1 over tan. Then all we can do is combine these by making a common denominator, which is cosine x. So I get 1 minus, this becomes cosine squared x. That's just basically what I did there, was made this like that, and then multiplied top and bottom by cosine, and then combine them. Now, one of the more important trig identities is that sine squared x plus cosine squared x equals 1, which can be rearranged various ways, and one of them is that 1 minus cosine squared could be changed into sine squared. So this is good because the goal was to get sine x involved, but where's tangent going to come from? Well, I can split this up into sine x times sine x over cosine x, and then I can split that up into sine x over cosine x times sine x. And the final trig identity is that tan is equal to sine over cosine. So this was like a trig identity question, but they didn't tell us that the goal was to convert this into that, specifically what it was going to become, so that was a little harder. Okay, finally part C. They have this equation. They want to know, find all input values in the domain of M that yield an output value of this. So we have to start with this. What are they getting at? Well, there are 3 really important, especially for the no calculator section, 3 really important angles that lead us to 9 really important trig facts. Sine, cosine, and tangent of 30, 45, and 60. You can see the denominator is always 2, but the numerator goes 1, square root of 2, square root of 3. Cosine goes backwards, square root of 3, square root of 2, 1. And tan is actually, you take the 2 numerators and make a fraction out of it. And this one, we usually make a square root of 3 over 3. Multiply top and bottom by square root of 3. So sine inverse of 3 halves is 60 degrees. Or in radians, if you like, or they like radians a lot on this test. In fact, almost every question seems to, that uses angles, does them in radians, so pi over 3. So this question is actually pi over 3 equals 2 tan inverse of square root of 3 pi x. Divide both sides by 2, or multiply both sides by a half. So tan inverse of this equals pi over 6. Another way to say that is tan of pi over 6 equals square root of 3 pi x. Now tan pi over 6 is actually one of our values. It's square root of 3 over 3. And finally, this is becoming an algebra problem. Divide both sides by root 3 pi. And the root 3's cancel. Don't forget the 1 on top. That's the answer. So that's going to do it for this third video about the sample AP test number 1. I've gone through all the questions, and I will try to do that for the other 2 tests in the coming days. Again, this disclaimer, I don't know that all these answers are right, but I do know that the explanations, at least, of what the math concepts are needed, those are accurate, but I might have made some careless errors. I apologize for those.